Welcome to section 1.6, function operations. You can see on the first slide it's an opener. So I'd like you to go ahead and pause the video for a few minutes, graph the piecewise function, and then answer the questions: where is the function increasing, decreasing, or constant, and what is the domain and range? Come back and start the video back up when you've completed it. Okay, and here are the answers that you should have came up with. Take a look at the piecewise function. You can see on the graph we are increasing from 1 to 3 and 3 to infinity. Be careful not to say 1 to infinity because it's not increasing at 3. We are decreasing negative infinity to negative 3. And we are constant negative 3 to 1. To get the domain, you can look at the graph, or you can just simply look over here. And to get to the range, you have to look at the graph. So let's start section 1.6. We're talking about operations with functions. We can add functions together, subtract functions from each other, multiply functions together, or divide functions as well. So in example 1, I give you 3 functions, f, g, and h. And for each one, we're trying to find the function where we add or subtract or divide or multiply the 2 functions together and then find the new domain. So first one, part A, says f plus g. So f plus g, this is f, this is g. So all we can really do there is combine like terms, and we get x squared minus 4. Since f's domain is all real numbers and g's domain is all real numbers, we can look at f plus g. That domain is also all real numbers, so the domain here is going to be all real numbers. The second one, we're taking g and subtracting f. So g minus f. Make sure you put f in parentheses there, or you might forget to distribute the negative sign. That's, sorry, supposed to be 2x there. So we have x squared minus 2x plus 4. So x squared minus 4x plus 4 is g minus f of x. So once again, g and f both have domains of all real numbers. G minus f is just a parabola, so it would also have a domain of all real numbers. So our domain here is all real numbers. Third one, f times g. So f times g. Distribute that out. We get 2x cubed minus 4x squared minus 4x squared plus 8x. So that would be 2x cubed minus 8x squared plus 8x. And once again, f and g both have domains of all real numbers. So f times g of x, that would just be a cubic function. That would also have a domain of all real numbers. F over g. So f over g is just 2x minus 4 over x squared minus 2x. Right, we can do a little simplifying here by taking out a 2 in the numerator and x in the denominator. And what we're left with there is just 2 over x. But be careful of the domain here. Obviously, we can't put 0 in the denominator, so 0 does not work. But what happens at x equals 2 is a whole. So that's also not part of the domain. So the domain for this one would not include 0 or 2. So that's your domain for D. Okay, and finally we have f over h. So f over h would be 2x minus 4 over root x minus 1. Nothing to cancel there, so that's it. That is f over h. However, for the domain, remember that x minus 1 has to be greater than 0. So x has to be greater than 1. So our domain for this one, it would be 1 to infinity. Parentheses on both. All right, third slide here is the composition of functions. So this little circle right here, it does not mean times, it means composition. We read that as f of g of x. You could also write it like this, f of g of x. So to do that, what we're going to do is we take a full function and put it inside of x for the different function. So let's take a look at the first example. It says f of g of x. So what we're going to do is we're going to take g of x and substitute in everywhere we see an x in f. So f of g of x would be x plus 2 squared minus 3. Technically that's it. We could expand that out to x squared plus 4x plus 4 minus 3 and x squared plus 4x plus 1. Either way, the domain for all those, there's no restrictions on g's domain, there's no restrictions on f's domain, so our domain is negative infinity to infinity. Okay, b looks the same, but it's a little different. It's g of f. So now we're going to take f and put that in for x and g. And pretty quick way to simplify that. Just combine like terms. We get x squared minus 1. Again, no restrictions on g or f. And this is just a parabola, so no restrictions again here. So last one, h of g. So we're going to take h, put that in to x for g. So that would be root x plus 4 plus 2. So this time we do have a restriction here. Remember, we can't take the square root of a negative number, so I need x plus 4 to be greater than or equal to 0. So x is to be greater than or equal to negative 4. So we bracket negative 4 to infinity. Okay, example 2. First one says find g of f. So we're going to take f and put that in for g, right into that x right there. So we get 1 over x squared minus 3 plus 2. So g of f of x is 1 over x squared minus 1. The domain cannot be positive 1 or negative 1. So our domain would be negative infinity to negative 1, negative 1 to 1, and 1 to infinity. So b just says take g of f that we just found here, and now we're going to substitute 3 in for x. So it's 1 over 9 minus 1, or 1 over 8. Example 3. So this one's a little different here. It says take f of x. So what you're going to do is take f of x and put it right back in for x in f. So f of x is 1 over x. 1 over x can simplify to just x. Okay, so it may look like that is all real numbers, but remember what you're doing is you're going to put whatever number we pick into here first and then put it in there again. So what number can we not put in the denominator? We can't put 0. So our domain here is everything but 0. Okay, the last one, f of g of x. So we're going to take g, put it into x for f. So you 1 over root x minus 1. So our domain again, we can't have 0 or a negative number in the denominator there because of the root. So x minus 1 has to be greater than 0. X must be greater than 1. So 1 to infinity. All right, so let's read number 4. Scratch off the your partners here since you're working alone today. Can you find two functions, f and g, that are f of g of x and g of f of x are the same? There are infinitely many correct answers to this problem. So pause the video, try to think of one, and then come back and I'll show you a couple different answers. All right, here's a couple different answers. So the first one that I have written down here is f is x plus 1 and g is x minus 1. So if you put this in here, you get x minus 1 plus 1, which is x. Same thing if you took this and put that in there, you get x plus 1 minus 1, which is x. So f of g of x and g of f of x are the same. And here I just have a couple of examples. So 3x and x over 3, x squared and root x, e to the x and natural log x. A couple different examples. Again, there are infinitely many correct ones for this problem. Hopefully you came up with one. All right, the last slide, you'll need a graphing calculator for. So if you want to pause the video and get a graphing calculator out. Once you have a calculator handy, let's go ahead and type that function into y1. So we have 0.9x cubed minus 3.2x squared plus 4.7. Now let's go to our window. The interval tells us from -2 to 4. We can always change the y window in a little bit. But let's go ahead and take a look at what this graph looks like. It looks like we do not need to change the y window because we can see the relative minimum and the relative maximum. Let's go ahead and draw a quick sketch of that. So we're actually going to find these first, the local max and min first on our calculator. So to do that, you're going to go to the second trace. And let's find the maximum first, so number 4. So go just to the left of that maximum point there, hit enter. Go just to the right of that maximum point, hit enter. And you can see, you might have to hit a third one that says guess. I'm not sure what your calculator is doing, but my calculator's already given me my maximum of 0, 4.7. So the local maximum would be 4.7. And that would be that point right there, 0, 4.7. All right, let's find the minimum now. So second, calculate, and number 3 is minimum. Scroll just to the left of that minimum, hit enter. Just to the right of that minimum, hit enter. And again, you might have to hit enter one more time for a guess. But my calculator is telling me 2.370, comma, negative 1.293. So my local minimum is negative 1.293. That'd be this point right here. 2.370, comma, negative 1.293. All right, so our increasing interval from negative 2 to 4 would be from negative 2 to 0, and then also from 2.370 to 4. And the decreasing interval is between those two. So a decreasing interval is 0 to 2.370. And that's a wrap on section 1.6. Homework is in the book. Tomorrow we'll do section 1.